This video is all about illustrating polynomial functions. By definition, a polynomial function is a function of the form p of x is equal to a sub n x to the power of n plus a sub n minus 1 x to the power of n minus 1 and so on up to a sub 0. Here, n is a non-negative integer. Isa-isahin natin. Ang ibig sabihin ng non-negative integer ay mga hindi negative na whole number. Number na mula sa 0, 1, 2, 3, 4, 5, and so on. So, kung merong negative fraction o decimal na power ng x or exponent ng x, hindi ito matatawag na polynomial function. Just like this, x squared minus 2. So the exponent here of x is positive and is a whole number, okay? Since the power or exponent is 2. Hence, this one is called a polynomial. Particularly, since it has two terms, it is called a binomial. Next, x cubed plus 4x squared minus 5x plus 3. Let us inspect each and every exponent of x. So for the first term, the exponent is 3, so it qualifies, it is positive, and it's also a whole number. The second term has an exponent of 2. The third term, the exponent is 1. So, this expression here is called a polynomial since it has positive and whole number exponents. Next, how about if we have only one number, and it's just 5? Can this be classified as a polynomial? The answer is yes, since we can have here x which has a power of 0. So it's 5x to the power of 0, and 0 is also a non-negative integer. Now, when can we say that it is not a polynomial? So again, first, if we have a negative exponent, just like x to the negative 2 plus 5. This expression here is not a polynomial since it has a negative exponent. And also, if we have an exponent of fraction or a decimal, like x to the power of 1/2. X to the power of 1/2 is the same as the square root of x. So if you can see a radical sign and x is inside that radical sign or square root sign, then that specific expression or function is not a polynomial. If you're going to expand x to the power of any negative exponent, it is the same as putting x on the denominator. Like say, if you have x to the power of negative 1, it's just equivalent to 1 over x. So, isa rin sa dapat nating tingnan is if our x is located on the denominator, then it is not a polynomial expression or polynomial function. Let's go back to the definition. So from the form of our polynomial function, we can see letters A with different subscripts. So from a sub 0, a sub 1 up to a sub n, these are any real numbers and also they are called coefficients. The first term that consists the highest exponent is called the leading term. So here in our form, it is a sub n x to the power of n. So it also consists of the degree of our polynomial function that will be familiarized later. Next, inside the leading term is the leading coefficient that is also a sub n. And lastly, the term with only number or constant in it is called the constant term. Ito yung term na walang katabing x. Most of the time, it is located on the last portion of our polynomial function. Polynomial functions are expressed using p of x, f of x, or y. Take note that these three are just the same. There are just some books and modules that use f of x most of the time. There are also some that uses variable y as a function of x. For this one, let's use f of x. Suppose we have this polynomial function here, f of x is equal to 3x squared plus 4x plus 1. Notice that we have 1, 2, 3, three terms. So this one is also called a trinomial. If you can see, there are different terms. So we have 3x squared, 4x, and 1. Now we are going to identify which term has the highest exponent or power, and that is 3x squared. This term here is also called the leading term. Notice that we have two numbers, and that is 3 and 2 in this leading term here. So 3 would be the leading coefficient, and 2 here is the degree. The term which has no x beside it is called the constant term. Alright, it can be any constant, it could be positive numbers, it could be negative numbers as well. Let's proceed to the types of polynomial functions. So the first type is zero polynomial function. It is also called the constant function. So sometimes it is expressed as p of x is equal to ax to the power of 0 or just a, where a is any real number. So halimbawa, if you have f of x is equal to 5, 4, 3, or any other number, even negative numbers, then it is a polynomial function, particularly a zero polynomial function. The next type is linear polynomial function. The linear polynomial function has only one degree. So it is usually in the form p of x is equal to ax to the power of 1. So the degree is 1 plus b, or it's just ax plus b. You have also encountered this linear polynomial function before in the form y is equal to mx plus b as a slope-intercept form. Next is the quadratic polynomial function. Its degree is 2. The form of this polynomial function is ax squared plus bx plus c. Next, we have cubic polynomial function. Its degree is 3. Its form is p of x is equal to ax cubed plus bx squared plus cx plus d. Next, we have quartic polynomial function of degree 4. So we have its form as p of x is equal to ax to the power of 4 plus bx cubed plus cx squared plus dx plus e. Let us try to determine this time if the given equation is a polynomial function or not a polynomial function. Let's start with f of x is equal to 4. This equation is, yes, a polynomial function, particularly a zero polynomial function or a constant function. Next, y is equal to 10x to the negative 2 minus 3x plus 1. This is not a polynomial function since the exponent is negative, or one of the exponents of x is negative. Next, we have y is equal to x minus 1. As you can see, the degree here, or the exponent of x, is 1. This is also a linear function. So in other words, it is a polynomial function. Next, f of x is equal to negative x to the power of 5 plus 5x. Let's inspect the exponent of x. So we have, for the first term, it is positive 5, whole number, and positive. So it is, the first term is safe. We have the next term is 5x. That's the exponent of x here. Okay, it is 1. So in other words, this is a polynomial function. Next, we have y is equal to 1 over 4x plus 3. Is this polynomial or not? It is not a polynomial function because x is located on the denominator. So if we are going to express this one in another form, the first term could be the same as 1/4 x to the power of negative 1. So since it has a negative exponent, then it is not a polynomial function. Next, f of x is equal to 12 plus 6x plus x squared. What do you think? Polynomial or not? It is a polynomial since all of the exponents of x are positive and are a whole number as well. Next, f of x is equal to 1/2 x squared minus 3. Glance at the exponent of x. So we have, for the first term, we have 2. And then, for the second term, we have a constant, 3. So take note that it qualifies since the exponent of x is a positive whole number. Here, its coefficient is 1/2. Any coefficient can be any real number, so this still qualifies as a polynomial function. You just take note of the difference, alright? In this portion here, we have a fraction and x is located on the denominator, so it's not a polynomial function. But if x is not located on the denominator and we have a fraction coefficient, then it's still a polynomial function. Next, f of x is equal to 1/2 square root of x plus 7. So just like what we had earlier, if we have a radical and then at that radical or inside that radical you can see x, then it is not a polynomial function. You just have to take note that the exponent, for it to qualify as a polynomial function, the exponent of x should be non-negative integer. Now let's proceed to mastering the identification of the leading term, leading coefficient, degree, constant term, as well as the type of polynomial function. So for this one, we have f of x is equal to 4x cubed plus 3x minus 7. So the term which has the highest exponent is 4x cubed. So this is our leading term. 4 is the leading coefficient and 3 is a degree. Since this polynomial function has degree 3, in other words, it is a cubic function. And then what is our constant term? That is -7. Now let's try to complete this table following the same example earlier. So we have polynomial function. We have two polynomial functions here. Let's identify the degree, the type of polynomial function, whether it is 0, linear, quadratic, cubic, quartic, and so on. And then let's identify also what is a leading term, leading coefficient, and constant term. So for the first one, we have f of x is equal to x cubed minus 4x squared plus x plus 6. Now what is the highest exponent? We have 3. So the degree is just 3. Next, since the degree is 3, then what type of polynomial function is this one? It is cubic. Yes. Next, what is the leading term? So the leading term is a term that consists of the highest exponent or the degree, and that is just x cubed. Next, how about the leading coefficient? The number on the left side of x for this leading term here, which is x cubed. Okay, since you have no number, it is understandable, alright, that it is invisible 1. Next would be the constant term. From this from this function, the constant term is positive 6. Next, we have y is equal to negative 2x cubed plus 5x to the fourth minus 2x minus 10. So what is the highest exponent here of x? We have positive 4. So the degree would be 4. Next, the type of polynomial function. Since the degree is 4, then it is quartic. Next, the leading term. The leading term is a term that consists of our degree or highest exponent, and that is just 5x to the power of 4. Next, the leading coefficient. So from our leading term, what is the number on the left side of x? That is just 5. Next would be the constant term. That is just -10. So that's just it. Now remember that not all the time that the first term already is a leading term, okay? So sometimes it is located in the middle part of the expression or the function. So you have to make sure to be keen and to be observant, to be clever, to identify which of the terms has the highest exponent. Okay?